Hi guys, here with your maths for today. We started this week by refreshing our memories on what fractions look like, what we call the various parts, what a denominator is, what a numerator is. We've looked at equivalent fractions and reminded ourselves that they're the same, they're just written differently. We're going to start looking at fractions that are greater than 1 today. Before we get started, some questions for you to get going with. Pause the video here to work these through. How did you get on with those? Looking at question 1, we did division last week, or we refreshed our minds as to how to do it. So you might have used one of the skills you learnt there. You might have remembered it from your times table knowledge, but we know that 24 divided by 4 is 6. Question 2, how many tenths is in one whole? Well, a tenth is one part of it, well, 1/10 of something. So it means that something's been split into 10 parts. So in one whole, there are 10 tenths. Knowing that, in two wholes, there are twice as many tenths, so there will be 20. And then the hundredths, so if something is in hundredths, it's got 100 pieces, 5 wholes, there's going to be 500 hundredths. So here we have 7 sevenths and 2 sevenths. How many sevenths have we got altogether? Well, I can work this out one of two ways. I can count them up, or I've got the denominators are the same. So I can just add the numerators. So 7 add 2 makes 9. So here I've got 9 sevenths altogether. So 7 sevenths equals 1 whole. So I know that I've got my 7 sevenths there. 2 sevenths, well, it doesn't equal a whole, it is 2 sevenths of the whole. So we know there are 9 sevenths altogether. That gives us 1 whole and 2 sevenths. Here I've got 2 sixths and 5 sixths. How many sixths do I have altogether? Well, 5 add 2, it gives me 7. So there are 7 sixths altogether. So I've got 7 sixths. So 7 sixths, I can make that into 1 whole and 1 sixth. So this is where we start getting into sort of what are called top-heavy fractions. We'll come back to those in a minute. So we're going to carry on showing this using the diagrams. So 7 sixths is 1 whole and 1 sixth. Have a go at these for yourself. Pause the video here. How did we get on with those? So our first one, how many fifths there are altogether? We need to count the yellow squares. There are 11 fifths altogether. So 11 fifths gives us 2 wholes and 1 fifth. So conveniently, the bottom row is already filled in. I just can take these 2 from the second row and move them up to the first row. So I've got 2 full rows for my 2 wholes. I've got 1 here that I haven't used. That's the 1 on its own, and my remainder, if you like. So 11 fifths is 2 wholes and 1 fifth. Looking at number 2, how many halves there are altogether? 1, 2, and 3. So 3 halves equals, and this one's been made nice and easy for us, 1 whole here and 1 half here. Well done if you got those. Now it's your turn. Before you start with number 1, they haven't really changed much. They're using part whole models to show you the wholes and how many parts there are that aren't a whole. So just look carefully at them. The answers are in there. They're easier to do than you think. Have a go. How did we get on? Are you ready for the answers? Here we go. So number 1, part A. There are 7 fifths altogether. So it gives us 1 bar with full with fifths. So it's 1 whole and there's 2/5 that are left over. B, there are 13/5 altogether. So we've taken the 2 full bars to give us our 2 wholes, and we've got 3/5 left over. C, we look at how many quarters there are altogether. There are 13. We've got 3 lots or 3 whole sets of quarters, and we've got 1 quarter that is left over. So 13 quarters is 3 wholes and 1 quarter. So using bar models here, check your answers against what is on the screen. Give yourselves a tick if you've got it. If you haven't, correct it and have a look through, see if you can work out where it didn't quite go the way it should have done. Right, mark your answers. If you feel like you need to go back, please do, and then come and join us again for the rest of the video. So 12/6, we call this an improper fraction. You might sometimes hear it called a top-heavy fraction. It's where our numerator is bigger than our denominator. So we've got sixths. So I've got my 6 here. I've got 1 lot of 6. So that's 6/6. And I've got the same again here, another 6/6. Now we can write it as 12/6, but it doesn't look right, and it's not the accepted way of doing it. And we know that if we have the denominators the same, we just add the numerators, which is what we've done here. We've added 6 and 6 to make 12 in the numerators. The denominators haven't changed. We are still talking about 6. So the other way of writing this, we can see we've got 2 full bars here of 6/6. So we've got 2 wholes. So 12/6 is the same as 2 wholes. How about 18/6? Well, I've got 1 lot of 6/6, 2 lots of 6/6, that gives me 12. And another lot of 6/6 gives me my 18. So 18/6 is the same as, or is an equivalent to, 3 wholes. So 18/6 is 3 wholes. There's 2 ways around we can resolve this. So if next time we have these, we don't have to spend our time drawing them out and counting the number of squares and making sure we've drawn them all to the same size and the same scale. There's an easier way of doing it. We look at the relationship between the denominator and the numerator. So in this instance, 18 is 3 times bigger than 6. Or 6 is 3 times smaller than 18. So we can divide the 2 by, so if you divide 18 by 3, you get 6. If you multiply 6 by 3, you get 18. So both ways around, you've got 3 wholes. So this works out really nicely, really neatly, where you have the numerator, sorry, the denominator is a factor of the numerator. So we have here, we know that 6 is a factor of 18 because 6 times 3 is 18. So as we said, 18 is 3 times greater than 6. 20/5 here. So we've got 5/5, another 5, another 5, and another 5. We've got 4 lots of 5/5. So 20/5 is the same as 4 wholes. So again, we can go and look at the relationship between our numerator and our denominator. And I know, and I'm sure you all know as well, that our denominator is a factor of our numerator. So we know that 20/5 is 4 wholes. We've done that with the diagram on the previous page. So 5 times 4 gives me 20. 20 divided by 4 gives me 5. So we can do it both ways round. We can check and make sure we've got it correct. So 20 is 4 times greater than 5. Now, I know, and I'm sure you do as well, 6 is not a factor of 10. So this is how we do it slightly differently. So I've got 6 sixths here, and I've got another 4 to give me my 10. So we count them up. We've got 6 at the top. 6 add 4 makes 10. So again, we're only adding the numerators because the denominators are the same. So I can do 6 sixths plus 4 sixths gives me 10 sixths. So I've got 1 whole and 4 sixths. So have a go with these. See if you can work them out. Pause here. How did we get on? So we've got 11 thirds. So we can draw out our bars with thirds and colour them in until we've used 11. And we should have 3 wholes and 2 thirds left over. 9 halves. So again, we can draw our bars out with our halves. We'll have 4 wholes and 1 half left over. 20 over 7, again, our bars will be split into 7s. I'll have 2 wholes and 6 sevenths. So looking at this one, I've got the same number of numerators. My denominators are different. So what am I going to put in my circle? I need to answer which one is greater than the other. So I'm going to need to draw this out. So I need 7 halves. So I've got 1, 2, 3, 4, 5, 6, 7 halves there. I also need 7 fifths. So I've got 1, 2, 3, 4, 5, 6, 7. There we go. No more than that. So 7 halves is greater than 7 fifths. So where the numerators are the same, the greater the denominator, the smaller the fraction. So if you look at the bars on the left, I've only cut them into 2. They've been cut in half. So 7 halves is greater than 7 fifths. So if you look at the bars on the right, where I've split the same size bar into 5, 7 fifths from that one are much smaller. They take up a lot less space. How about this one? I've got 24 sixths and 16 fourths, or 16 quarters. Let's work it through. I've got 1 bar of 6, 2 bars of 6, 3 bars of 6, 4 bars of 6. I've got 4 wholes here. I've got 1 bar of 4, 2 bars of 4, 3 bars of 4, 4 bars of 4. I've got 4 wholes here. They're the same. They're an equivalent fraction to each other. So we were looking at equivalence yesterday. These are both worth 4 wholes. So have a think for yourself. 2 wholes and 3 fifths. Is that the same as, greater than, or less than 9 fifths? Is 28 sevenths the same as, greater than, or less than 12 thirds? And then question 3, are 9 sixths greater than or less than 17 eighths? And number 4, is 20 tenths greater than or less than or equal to 20 ninths? Pause here to have a go. How did we get on with these ones? So if you're drawing them out, make sure you've got the right number of lines, the right number of bars in each one. So 2 wholes and 3 fifths is greater than 9 fifths. So 2 wholes is worth 10 fifths. 10 plus the 3 is 13, 9 fifths. So 13 is greater than 9. 28 sevenths and 12 thirds. They're the same, they're equal. So 9/6 is less than 17/8. And 20/10 is less than 20/9. So we need to be careful. Number 4, we've got the same numerator. Remember, the bigger the denominator, the smaller the value. So 20/9 is greater than 20/10, or as it's written in the question, 20/10 is less than 20/9. Now it's your turn. Have a go at the questions. If you get stuck, that's nothing to worry about. We can go over them in our live session later today or tomorrow. You can post your questions in our chat. I'm happy to help. Pause here to complete your work. How did we get on with these? Ready for the answers? Okay, question 3. A, 12 halves is the same as 6 wholes. B, 12 quarters is the same as 3 wholes. C, 12/6 is 2 wholes. D, 12/3 is 4 wholes. E, 15/3 is 5 wholes. F, 15/5 is 3 wholes. G, 15/4 is 3 wholes and 3 quarters. H, 15/2 is 7 wholes and 1 half. Question 4. Whitney bakes 26 muffins. Muffins are packed in boxes of 4. How many boxes can Whitney fill? She can fill completely 6 boxes. And how many more muffins does Whitney need to fill another box? She needs 2 more muffins to fill another box. So to explain how you know, she will fill 6 boxes with 2 left over, so another 2 are needed to fill the 7th box. So it's using our division skills from last week again. So it's just the fractions relies on us using division as well. So writing 26 over 4, how does it help you answer it? It shows you the relationship between the number of muffins you've got and the size you need to fill a box. So it gives you the number of holes that you will have. Question 5. A, 2 wholes and 3 quarters is greater than 5 quarters. B, 2 wholes and 3 quarters is less than 15 quarters. C, 2 wholes and 3/6 is equal to 15/6. 2 wholes and 3/8 is greater than 15/8. E, 15/3 is greater than 15/5. F, 15/3 is equal to 20 quarters. Completing the part whole models. 4 3/5. So A, 4 3/5. So 3/5 is your missing answer. B, 4 3/5 is our whole. 3 has been taken away from the part as one of the parts. So what's left is 1 3/5. C, 4 3/5. So we've taken 13/5. That's the same as 2 3/5. So the missing number was 2. Well done today. You've worked really well. If you've got stuck, again, message me in Teams. I'm happy to help through. If I need to, I'll do an extra video and talk you through as we've done before. Well done today. Take care, stay safe, and I'll see you again for our next one.